Okay, so we're just playing a little bit of song requests, I guess, except we're not songs. We've got questions. So this is review B, and our requesting student today is Bobby, and we've got the volunteer, Kunal. Did you want to take care of this one? So choose your colour poison.
How do I get the mic?
And you get the mic. I apologise for what is to happen, people. He might be singing.
Oh, yes, I will be singing. Let's go with white, honestly. No particular reason at all. So, let's make a diagram. Oh, I can't. Wait, which one's the line? Is that the line? Okay. Oh. That's beautiful.
But you don't know what the modulus is, so we're trying to think when we see that, if it hasn't given us z equals a plus bi or w equals whatever, try thinking
Diagramize. Okay, and then I actually need to write this. So let's let that be. Oh no. There you go. Okay, so let that be Z. Let that be W, sorry. And then, obviously, this isn't in the scale. What's that? Z minus W.
Z plus w represent.
Yeah.
What does it represent? The
Hold
length
up.
of Z plus w. So maybe go ahead of Kunal and, add them up. But it's pretty much similar to the diagram that we had the other day.
Yeah, I shouldn't I? I'm sorry. Look, I am very, very lazy. Fine, I'll do it. 3. Hate you, man. And then,
Very good, very good.
then there you go. Right, and then we get the pen. Yeah, that works. Then that's also W there, but then together that becomes. So that's W. Then this is Z plus W. This is Z here.
Sorry, just interjecting just a little bit. Do make sure that you pop your
Arrows, yeah, for the vectors.
because you're representing them as. Oops, sorry, put you back. There you go.
Oh, thank you. I'm gonna have this a different color. Let's go pink. Was that chosen? Yeah, there you go. This becomes Z plus W, or what? Actually, pen. Oh no, why isn't it? Z plus W, and then the middle line is Z minus W. Oh, I should.
And why is your middle line Z minus W?
Oh, because it is subtracting W from Z.
Right, it's asking you what is the distance between Z and W. I would sort of normally.
Didn't work. Don't worry about that.
Vector thing and look at it, and you again like we did on that blue sheet. You know what I'm talking about with the blue sheet?
Now, clearly.
Sorry,
Can I write?
interrupt you for
yeah.
a moment. So Kunal's done a great job. He's not going away. He's nearby. But if you look up your the triangle inequality, Bizzo, that's where we discussed about how we get what is Z plus W, right? And then Z take W. And you can see if they are the same vectors, they don't actually equal each other. This blue line and this one aren't necessarily always going to equal each other. Would you agree? And even with the Kunal's diagram here, you can see they're not necessarily equaling each other. But the question is asking you if they do, right, prove that they differ by. So handing back over now.
I'm back. Now, I need to actually show that that middle line is Z minus W, if I can actually draw it. You know what, that works. And then that blue line is Z minus W. Now we go to writing. Now, clearly, actually, let me give these points. Let's go red. So origin's there. This point here is A. This point here is C. This point here is B. Yeah, why not? Clearly, OABC is a parallelogram. That's where it comes in. Parallelogram. Oh, full stop there. Yet, if you think about it, if Z plus W equals Z minus W, OABC is actually, oh, I can't spell, sorry. Why? Yeah, is actually a rectangle. Yeah, I'm sorry. Alright, wait, go down. Go down? Oh, yeah. Is a rectangle, and therefore, angle COA actually equals 90 degrees, and therefore the argument Z and argument W differ by pi on 2, as I'll show just differ by pi on 2 because of the 90 degrees. If I go up, because if that becomes a rectangle, that, oh damn, yeah, if that becomes a rectangle, then it differs by 90 degrees. Pi on 2. Oh yeah, I can't. Yeah, I don't have a point on this.
Very good. So basically, this thing here,
Yeah.
right, has to be a rectangle.
Yeah, if it were,
So that's your Z.
Yeah.
That's your W, and then that's you're talking.
Yeah.
They can't hear me.
Oh, that angle becomes pi on 2.
But yeah,
But
that angle is arg.
Yeah, that's arg Z subtract arg W.
Yep. So that becomes this.
The difference becomes pi on 2 as it turns into a rectangle, which has to be 90 degrees because it's a rectangle.
There we go.
And that is it.
We just went through a question from 4F3, but there are videos for that for those of you playing at home. So check Daymap and check Teams. Can't really remember where I popped them, but I think I put them on Teams. Otherwise, YouTube, man, in my channel. All right, so this one, it says list the zeros, list the fifth roots. So that's when we're going to use the formula, right? So remember the formula we've written? Yes, G? Happy with the formula? Do you know what I mean when I say formula? We just talked about that before when we've got Zn equals 1, right? The roots are going to be 1, W, W2, all the way up to Wn take 1, where W equals cis 2 pi on n. So for this one, it hasn't said show that the roots are, it hasn't said prove, it hasn't said use de Moivre's theorem, it's just saying list the roots. So for Z to the 5 equals 1, my roots are going to be in terms of W, so Z will be 1 W, W squared, W3 and W4, where W equals cis 2 pi on 5, right? When we now want to draw these, what is it that we have to remember when we're drawing the complex numbers on our Argand diagram? What do you mean they have to be the same? Right, so they're evenly spaced, right? They've got to be evenly spaced. And of course, they've obviously got the same length. So the best way to do that, and in this case, our length is just 1. So the best way to do it is to have your circle. Oh, not bad at all, they say. I'll stick with the yellow. Oh, ruined that one just a bit. That's okay. So Z equals 1. So we've got our 1 over here, and we'll call that 1. Where is our first W? So our first W is going to be 2 pi on 5. Now, to be honest with you, what I do is I grab my calculator, because I'm fractions, it's on the end of the week. I grab my calculator and I go, what's 360 divided by 5? Right, so what's that? 72.5, right? 72.5 degrees. So I can now judge where that's going to be, right? Here's 90 up here, pi on 2, whatever. So 72 is maybe around here. Would you agree? So this is W. W. Now, I can go and do the next one. What's 72 plus 72? So 144 plus a little bit. So maybe it's around here, right? I mean, obviously, if I've got my calculator, it's a little bit better. But my next two, what do I have to make sure? Yes, they're evenly spaced, but remember, we've got conjugate pairs. So this one here, right, it's going to be the same, right? That angle there has to be the same as that angle there. So they're going to look for that in your diagrams, that they have to be evenly spaced. So 1, yes, evenly spaced, but also that these are the same angles. Why? Because they're conjugate pairs. And we know that the conjugate of a complex number is reflected in the x-axis, okay, in the real axis. So that becomes W, what is this, 5th root 4. And then this one here, and hopefully, do they somewhat look evenly spaced? Not too bad. If it is the fact that, you know, it didn't work out too well, you could put a little, they should be evenly spaced, right? Or actually draw in your diagram there if you so desire, right? Because obviously that's 2 pi on 5. That's 2 pi on 5. So if your diagram looks a bit shonky, just add to it and hope that they accept that. Okay, the next bit. Sorry, I'm going to just erase some of this stuff. So I've got room to move. B, by considering the factorization, by considering the factorization of z to the 5, take 1 in 2 different ways, show that that is that. Okay, factorization, 2 different ways. How do we normally factorize or work out how we can factorize polynomials? We had, got a little bit of an issue there. I mean, can you look at that? I mean, this is giving you a little bit of a heads up here that it's 1 less degree. So can we think of how do we get 1 less degree? Come on. Psst. I'm worried it keeps flashing. Or is that me pressing it? Come on, guys. How do you go 1 degree down? Sometimes we could say, well, we could pull out a common factor, but that would mean we would have to have 0 as a 0. So you could just stick out z at the front and go, oh yeah, boom. But how is z to the 5 going to get us the z to the 4? Think about how we go a degree down, yeah? I mean, this is a bit of a clue. We've got 1, 0. We know it's z take 1, but then how do we know? So I agree with you. We've got z take 1 times, but how would I know what's here? We do the division. Now, you can do long division or you could do synthetic division. So let's go with, so we've got 1, that's 4, z to the 5, 4, 3, 2, 1, and your constant term. So because 1 is our 0, we plop that there, 0, 1. 1 times 1, 1, 1, 1, 1, 1, 1, 1. Oops, that should be a minus, good. 1, and that becomes minus. And lo and behold, you get 1, that's your z, that's your z squared, that's your z cubed, that's your z to the 4th, correct? So, if I had z to the 5 take 1, I would factorise that to be z take 1 times z to the 4 plus z cubed plus z squared and so on and so forth. I've lost the break. Do you agree with that? But let's look at what it's asking us to do. It's asking us to do this. Why can this section here factorise to be this? Yes, Mac? Because those are your remaining roots, absolutely. So we already know we've used up 1 over here. So this whole factor there, z to the 4 plus z cubed plus z squared plus z plus 1 has, oh, what's happened to my board? Has roots w, w2, w3, and w4, does it not? Therefore, this thing here must equal z take w, just like we said 1 was a 0, therefore z take w was a factor. Well, this would be z take w squared, z take w cubed, and z take w4. Oops, w4, I just wrote 4. No, I have to redo that. Making the sense? So maybe you should write a little bit of an explanation as you go along. That's not too bad. Oops. Okay, last bit. Hence, how is this connected with this? Right, they're saying here, just sub in z equals 2. And see what you get. As your root, yeah. What's that? 16, 8. What is that? 24, 28, 30, 31.
Hi guys, so we'll be doing a review set 4A, question 12A. This one, the cool argument one. So we have argument z subtract I is equal to pi on 2. Oh, hi man. So if we know if the argument is pi on 2, we know that it must be purely imaginary. Must be equals purely imaginary because it only lies on the imaginary plane on the Cartesian thing. Purely, and we'll just go like image.
Hang on. Do we agree with that?
I mean, I do.
No, but isn't that saying, oh, I see. I got you.
Yeah. And then we have
Wouldn't that be though, you've got two different ones, it's 90 degrees between the two. So it could be anywhere.
I mean, I got the right answer book.
Yeah, I get you, but I
Yeah.
because the z is minus I is. But anyway, carry on.
Alright, let's actually go. Well, when we have to let z equal x plus iy, right? And then we go, so we have argument z subtract I, and that will equal, when we sub in z, sub in x plus iy for z, it'll equal, I should probably be trying to write in the grid, a little better. We'll try writing the grid a little better. Equals arg x plus I, y, subtract I. Then we take out x plus, we take out I as a common factor. And we go y subtract 1. Therefore, and we need this whole thing to be imaginary. So therefore, x, for it to be purely imaginary, and actually let's do the whole thing up here as well. Where's the line tool? Get the cool line going.
Could you tell me what M stands for that y equals mx plus c?
No, I can't. No. We'll draw the Cartesian line as well, just so it makes it a little easier. We'll go for like a cool different color, yellow. So if it's pi, we know this is pi onto this bit. Why is this not yellow? Maybe this is pi on 2. So then, to make this bottom part, we need this part to be purely imaginary. X has to equal 0. And for this to be imaginary, we need this to be y is equal to, no, sorry, y is greater than 1 because it is y subtract 1, y is equal to 1. Y cannot equal 0. Okay, this is kind of scribbled, but y cannot equal 0, therefore y has to be greater than 1. Does this make sense at all? I was kind of saying it kind of quiet, and I didn't really explain it very well.
So talk to him, man. I'm just putting some intelligence.
I'll put the microphone back. So
hang on.
So because the argument is pi on 2, it's going to be purely imaginary. And when you sub in x plus I, y for z, you take out the factors so you can make it whatever you really want to. So when you take out the factors and take out I as a common factor, to make it purely imaginary, there can't be any real component, so x has to equal 0. And because there has to be an imaginary component to make it purely imaginary, y has to be greater than 1, because if it's below 1, it's going to be negative pi on 2, because it's below the real axis. Thank you, Canal. It's kind of a weird. That's my bad. If it's kind of.
Well done.
Thank you, miss.